So let's look at adding and subtracting rational expressions. Again, anytime you add or subtract a rational expression, you absolutely need a common denominator. That's a skill that you need to come into this class with. So if we have x plus 2 over x, one of them has a denominator, one of them doesn't. Quite simply multiply the first term by x over x to get it to have a common denominator. So if I multiplied it times x over x, I'd have x squared over x plus 2 over x. Now they both have a common denominator, so I'm actually able to add the numerators and keep the denominator exactly the same. So the denominator stays the same, and I add the numerator. That's how I would add the two fractions if that's what the problem were. So you have to be confident with getting that common denominator. Let's look at part B here. Part B is a little more difficult. It's 2 over x plus 1 minus 1 over 2x plus 1. How am I going to do that problem? Well, the first thing that I'm going to do is rewrite it so I can get a common denominator here. Give me a second. So I have 2 over x plus 1 minus 1 over 2x plus 1. I need to look at what's the first one missing. Well, the first one is missing the second one's denominator, so I want to multiply the first one by 2x plus 1 over 2x plus 1. What's the second one missing? The second one's missing the first one's denominator, which is x plus 1. So I'm going to multiply both the top and bottom by x plus 1. So it's x plus 1 over x plus 1. Again, all I'm doing is multiplying each one of these times the number 1. I'm just multiplying each one of these times the number 1. Now I need to distribute. So I'm getting a common denominator, so I'm going to distribute the 2x plus 1 times the 2, and I'm going to distribute the 1 times the x plus 1. That's not too hard, but let's see here. 2x times 2 would be 4x, and then 1 times 2 would be plus 2, and this is all over 2x plus 1 times x plus 1. Minus, on this one, 1 times x plus 1 is quite simply x plus 1. On bottom, I now have my 2x plus 1. Notice how I put that in parentheses. It's very important. All over x plus 1. Now my two denominators are the same, so I can subtract the numerators. I want you to be very, very careful on this step. Very careful on this step. This would be 4x plus 2 minus x plus 1. I want you to notice how I added parentheses around each one of those terms. So 4x plus 2 has parentheses. That's not really necessary, but what's absolutely necessary is the parentheses around that x plus 1. In bottom, we have the 2x plus 1, and we have the x plus 1. Why is it so important? I mean, I cannot highlight this step enough. So important to put those parentheses there. Why is it so important? Because in the next step, what we need to do is distribute that negative. I've told you multiple times already, one of the biggest issues that you're going to have this semester, or that most students have algebraically, is forgetting to distribute a negative. So on top, I would really have 4x plus 2. I would have a minus x and a minus 1. Almost all students who make an algebraic error would do a plus 1 on that problem. So here's a 2x plus 1 and an x plus 1. Combining like terms, 4x minus x would be a 3x, 2 minus 1 would be a plus 1. This would be all over 2x plus 1 in parentheses and an x plus 1. Parentheses matter. Yes, you do need them there, so make sure you have them. Last thing is just check to make sure. Look, there's nothing in common here. We have no common factors, so that is my final answer. Let's go on to the next one. How do we do subtracting rational expressions here? So subtract the following rational expressions. Well, what do I need to do? I need to make sure they have a common denominator before I'm able to do anything. I am looking at this little bottom right here. It's 1 over 3 times the quantity x squared plus 2x minus 1 over 3x. Well, looking at that x squared plus 2x, I notice, isn't there an x in common there? So if I factored out that x in common, I'd have an x plus 2. So really what I want to think about this is 1 over 3x times x plus 2 minus 1 over 3x. And the reason that I did that is because that makes it easier for me to find the common denominator. So when I look at that second term, that minus 1 over 3x, I really don't need to multiply it by the entire first denominator. I only need to multiply it by what's missing. So it's only missing the factor of x plus 2. So I'm going to multiply both the top and bottom by just x plus 2. So here I'd have a 1 over 3x times x plus 2. Now I'd have a minus, well, 1 times x plus 2 is simply x plus 2 over 3x times x plus 2. Now I have that common denominator, so I'm able to subtract those numerators. Hopefully you catch it here. We have to put those parentheses around that x plus 2 when we subtract it. You've got to put those parentheses there. And again, why is it so important that you put the parentheses there is because we need to distribute that negative to both of those terms. So what I really have on top is a 1 minus x minus 2 all over 3x times x plus 2. Let's write that in proper form here. Well, I'd have a minus x, and then a 1 minus 2 would be a minus 1 all over 3x times x plus 2. I don't know if it's driving you nuts. I noticed that there's a negative in common on top. I could factor out the negative. That's not going to do me any good, though. So I'm fine with you stopping the answer right here. If you factored out that negative in the numerator, that's perfectly fine as well. Totally up to you. All right. Here's something you're going to see within the next week or two without a doubt. It is really, really important that you know how to simplify these types of fractions. This x plus h thing is something that's not going away anytime soon. You are going to see it. So let's look at this first one right here. It's 1 over x plus h minus 1 over x. So how am I going to handle a problem like this? Well, I need to multiply by the missing term. So the first term's missing an x over an x. The second term's missing an x plus h over an x plus h. Multiply by the missing term in both the numerator and the denominator. So when I do that, on the first one I'd have x over x plus h, and on the second one I'd have minus x plus h all over x times x plus h. Now my denominators are the same, so I can subtract them, keeping the denominator the same, subtracting the numerators. Again, though, I cannot express how important it is. You have to distribute that negative. So I'd have an x, and then I'd have a minus x, and I'd have a minus h when I distribute the negative. You have to remember to distribute that negative. On top, notice those x minus x are going to cancel. So I'm left with a negative h all over x times x plus h. No other common factors there, nothing else that I could do. That would be my final answer. Let's go on to B here. B here, two different strategies that I can teach you on this. This is called a complex rational expression, where you have fractions over fractions. Those are always a pain in the butt. So two different strategies. The first strategy would be look at just the numerator, the 1 plus 1 over x plus 1, and treat that as a single problem. If you treat that as a single problem, make that into a single fraction. And then look at the denominator, the x minus 4 over x. Treat that as a single problem and make that into a single fraction. Then you're going to have a fraction over a fraction. You keep change flips. So let's do that strategy right now. If I were to do that strategy, what I would do, let me rewrite this. So I have equals, and I have the 1 plus 1 over x plus 1 all over x minus 4 over x. Think about just working with that numerator. I would need so I'm literally just working on the top. All I'm caring about is the 1 plus 1 over x plus 1. So what I'd do is I'd multiply this first term times x plus 1 over x plus 1. That's going to give me a common denominator. So I'd have what? I'd have x plus 1 over x plus 1 plus 1 over x plus 1. And then if I combine those, I would have, because they have a common denominator, I can combine them, x plus 1 on bottom, and I'd have an x plus 2 on top. I'd have the x plus 1 plus 1. Okay, so that's what that's written as a single fraction. Let's go back and look at the denominator now. I have x minus 4 over x. Well, to get a common denominator, I need to multiply the first term by x over x. So that would give me x squared over x minus 4 over x. Those have a common denominator, so it would be x squared minus 4 all over x. So that's what happens if I treat both of them completely separately. Now if you notice, I have a fraction over a fraction. And if you remember, it's keep, change, flip. So this is the fraction that I need to flip, the bottom one. So this is the exact same thing as x plus 2 over x plus 1 times flip the bottom fraction, that would be x over x squared minus 4. All right, well, we're not done with this because we need to see if we can simplify this at all. If you notice, x squared minus 4 is a difference of squares. So really this is x, maybe I can write it like this, x over x plus 2 all over. Here on the bottom I'd have an x plus 1, but x squared minus 4 actually factors into x plus 2, x minus 2. Now if you notice, the x plus 2's are common factors. I can simplify those. On top I'm left with x, on bottom I'm left with x plus 1, and also an x minus 2. Whew! There's a lot of work on that problem, a lot of places that you could go wrong, but that's how you would do that one. I'm not going to lie, a lot of students would stop this problem at this point right here where they had x plus 2 over x plus 1 times x over x squared minus 4. They wouldn't have tried to factor that x squared minus 4 and continued the problem all the way.